Hello guys, and welcome back to our YouTube channel. So in this video we are going to solve the question 4 of June 2023 GCE, that is the General Certificate of Examination Board. And the question is simply saying that given that f of x equals sine x, the ln of tan x, find f prime of x when x equals to pi on 4. Well, f prime of x just means the first derivative of f of x, and after that you evaluate it when x equals to pi on 4. And the second part is saying we should do that integral using that nice substitution. Okay, well, you see that when what we have been simply been given is that f of x is a product of two functions, using so that we can use one of the techniques of differentiation. So one of the techniques in differentiation is what we call the product rule. When you have product of two functions, you can apply the product rule to find the derivative of that function. So in this case, we will say that let our function be made up of two functions. Like this one, I can call it u, and this one I will call it v. Then my f prime of x will be equals to u prime v plus v prime u. That is, I'll differentiate u, I'll allow v constant, then I'll differentiate v, I'll also allow u constant without changing it. So that is the product rule. Now to apply it here simply is that, so since we have said, so let us take it gradually. Since u is equal to sine x, then the derivative of u, that is du dx, will be equals to cos x. Well, some people always confuse between the derivative of cos and sine. Is it sine that is giving negative cos, or is it cos that is giving negative sine? The first thing I would like to tell you is that the derivative of all trigonometric functions beginning with c, the letter c, are negative. So the derivative of cos is negative, the derivative of cot is negative, the derivative of cosec is negative. So the derivative of cos is giving you negative sine x, while the derivative of sine x is giving you positive cos x. I think with this you can remember it easily. Okay, now, so if we go again on our v, so our v, let me change the color. So our v is equal to the ln of x. Well, there is a formula that when you have a function, let us just say tan x is u. So where the derivative of ln u is simply equals to u prime on u, right? In our other videos, in our future videos, we may derive it. Okay, so the ln of u now, so we are now having our u to be tan x, and the derivative of tan x is simply sec squared x, and dividing by our u, which is now tan x. So this is now our dv. So our dv is this, and our du is that, or our dv dx. So we are now having our v prime. This is equals to v prime, and this one here is equals to u prime. So we now just go ahead and apply our formula gently. So f prime of x will be equals to, we said, u prime v. So our u prime is simply equal to x, and our v is simply the ln, the absolute value of tan x. Ln is in log function, it has to be positive, plus down here, plus v prime, which we got to be sec squared x, all on tan x, multiply by u, which our u in this case is sin x. So you can go ahead and just evaluate this. Well, all of these functions in your calculator. So what you just need, let us just simplify this sec function. We'll be having f prime of x will be equals to cos x, the ln of tan x, absolute value, plus sec is simply 1 on cos, that is the one having sine, s is simply c. So by having sec squared is 1 on cos squared, so we'll be having 1 on cos squared x, then having tan x on the bottom, we multiply that our sine x. Now we'll just go ahead and apply put our f prime of pi on 4. So that is our f prime of x. Now f prime of pi on 4, don't always simplify, please, just allow answer like that, it's okay. So our f prime of 4 simply be cos of pi on 4, then the ln of tan pi on 4, plus 1 on the cos of pi on 4. Please, when we say cos squared, it does not mean that we mean that you should find the cos of the angle, then you square the result. That is the meaning. all that we multiply by sine pi on 4, all that on tan pi on 4. By the way, tan pi on 4 is product of this cos pi on 4. So if you do it like that neatly, you just get cos pi on 4, cos 45 is simply root 2 on 2, 2 on 2. The ln of tan pi on 4 have to be 1 since sin pi on 4 is also root 2 on 2. So the ln of that, so we're having the ln of tan pi on 4 is 1. So we're having ln 1 plus 1 on root 2 on 2, which is cos pi on 4. But this one now is squared. Multiplied by sin pi on 4, which is also root 2 on 2, dividing by tan pi on 4, which is 1. Right? So now we just simply get ln 1 is 0. So we just get 0 plus. We have up the numerator, we have root 2 on 2. On the denominator, we simply have our root 2 on 2, all that squared, multiplying by 1. So we just simply get 0 plus root 2 on 2 on root 2 on root 2 on 2 on 2, multiplying by 2 on root 2 on 2, all that squared. So we just get 0 plus root 2 on 2 on 2, multiplying by 4 on 2. Right? And we just simply get 0 plus this 2 and 2 cancel with this 4, get 0 plus root 2, and we get our f prime of pi on 4 to be equal to root 2. And that is your final result. So let us move to the second part, which is under integration. It's saying that we should find the integral. Let me change my pen. We should find the integral from 1 to 10 of x dx, all on the square root of x minus 1, using the substitution u equals to x squared minus, using the substitution u squared equals to x minus 1. Hey, the integral is from 2 to 10. So you have to evaluate the integral. Evaluate the integral from 2 to 10. U squared equals to x. So it's equals to x minus 1. So we're having u squared be equals to x minus 1. Okay, now what you do here is simply to substitute. Substitution means your dx, you replace it with something in terms of du. Your x's, everything you change, even your limit of integration will change. Is it okay? If you don't want to use the substitution, or you can still do the substitution, you integrate, then when you come back, you replace your u with x, which is more work. So the best way is just to substitute everything. So let us share our board and then okay, let us have shared my board. So let us say we are having u squared to be equals to x minus 1. Now what you will find is simply what is u will be equals to this plus or minus, but just take the positive. U will be equals to this positive square root of x minus 1. And now we are having that x equals, we are having some values of x, that is x and u. The limit we are starting from 2. So when x equals to 2, what will be your u? You put 2 here, 2 minus 1, the square root of that will just simply give you the square root of which is 1. And substitute now when x is 10. When x is 10, you get 10 minus 1, which is 9. 10 minus 1, which is 9. Then you take the square root of it, you get 3. So when x is 10, u is 3. Now, the next thing again, you look now for you differentiate both sides so that you replace your x and differentiate with, you get your dx. So we'll differentiate the both sides. So the derivative of u will differentiate both sides. So the derivative of u squared plus x minus 1. So if we differentiate this, the derivative of u squared is simply 2 u du. It's simply 2u du has to be equals to dx, the derivative of x, that is the derivative of x to the n, is simply nx to the n minus 1. So our n here is 2, so we bring down the 2, and then 2 minus 1 will be left with our 2 minus 1 will be 1, so we just get 2 into u to the power 1, which is just u. And now for the x, we differentiate, x is x to the power 1, you bring down the power 1, Then you subtract x to the power 1 minus 1, so you'll be having x to the power 1 minus 1, which will be x to the power 0. Anything to the power 0 is 1, so you'll be just leaving your 1 then dx, since you are differentiating with respect to x. The derivative of a constant is 0, that is the derivative of negative 1 is 0. Now we continue and we now then look for our what is our x again, because we have the substitution for dx. Now our dx is simply 2u du. Now what is our x? From here I know that u squared is equal to x minus 1. If I take this one to the other side, that will u squared plus 1, it is crossing the equal sign, equals to, so my x is u squared plus 1. So I'll just go ahead and replace everything in that our integrand. So in our integral, we'll now be having the integral from 1 to 3 in terms of u, by using now u limit, will be 1 to 3, and our x dx will now be having the u squared plus 1. This is my x, which is u squared plus 1, multiplied by dx, which is what, 2u du. All that I divide by the square root of x minus 1, which is what, u. Use it here. So all that on u. You see now, substitute everything is now in terms of u. You then do your integration very easily. So now we can just see that this u cancels with this u, and these two I can pull it out of the integral sign, so we'll be having, or I can multiply all through, so we'll be having our, we'll now be having the integral from 1 to 3 of 2u squared plus 2, all that du. Just open the bracket here. Now to integrate, you know that the integral of x to the n is simply x to the n plus 1 and n plus 1. Now we are integrating 2u squared, so we'll be having the integral, we are integrating 2u squared with respect to u, so we'll be having 2u to the power 2 plus 1 and 2 plus 1, plus the integral of 2 is simply 2u, that is just like 2u to the power 0 here. Now you add 1 to the 0, you get 1 dividing by 1, so you just get 2u. That's the integral of 2. Okay, now we put now our limit from 1 to 3 without now putting our du anymore. So we now put, so we substitute the upper limit. Before we substitute, let us first simplify. So we're having 2u cubed on 3 plus 2u from 1 to 3. So we substitute our upper limit. So substituting this is what we call the upper limit, this is what we call the lower limit. So we substitute our upper limit, then we subtract from the lower limit, as we have the integral of f of x from a to b will be equal to, let us say our answer is gram f of x from a to b. It will now be what, f of a minus f of b minus f of a. So we just now do our f of our f of 3, our f of 3 minus the f of 1. So we just take 2 into 3 cube on 3, 2 into 3 cube on 3 plus 2 into 3. That is, I'm substituting u value to be 3 for the upper limit. So we just get, let me first simplify this. So we get 2 into 27 on 3 plus 6. So we now just get 3 and 1, 3 and 9, 2 times 9 is 18, 18 plus 6 is 24. So we get 24 for the upper limit. Now we substitute our lower limit. We'll now be having lower limit. We'll now be having 2 into 1 all that cube on 1, no, on 3, since I'm substituting the u, plus 2 into 1. So I'm just simply getting 2 on 3 plus 2, right? Now we now simply see that we are getting 2 on 3 plus, I can just say this one to be 2 times 3 over 3. This is t1. So now we'll be having this what we call like fractions in primary school. Very easy to add. So we now maintain our denominator 3. 2 times 3 is 6 plus 2 will be having 8 on 3, right? So now we now have our integrand from 2 to 10 of x dx, all on the square root of x minus 1, will now be equal to 24 minus 8 on 3. And 24 minus 8 on 3, you can still find your LCM, or you can multiply both sides by 20. So I can say 24 or multiply by 3 or divide by 3 minus 8 on 3. So 24 times 3, let me say 3 times 4 is 12. You have 2 and carry 1. 3 times 2 is simply 6 plus the one we carry, 7 minus 8 and 3. And 72 minus 8, let us say 72 minus 2 is 70 minus 6 is simply 64 on 3. So our integral will be equal to 64 on 3. So thanks for watching and have a great day. The key thing is that you just substitute gently. Substitution means you replace all the variables with the new variable that you have to substitute with. And you just simply take your time and you simplify. So thanks for watching and have a great day.